Here, the polygon. Does that make sense, really? Heck no. Maybe. Okay, so how about the next one? Means if you extended the sides of a polygon to make lines, none of them would go through the inside of the shape. Okay, so if you extend any side the lines don't go through the middle. Of whatever shape you're talking about. So does this make sense? Well,
Yeah.
make a pentagon, right? What's a pentagon?
5 sides.
5 sides, right? Okay, so I have my pentagon. And now if I extend the sides, no matter where I extend the side, this way, this way, this way, see how it never goes through the middle of it? Or the inside of it? That makes it convex. So if you want to come back and just say it's not on the inside. So then concave would be just the opposite, right? So if we came back to this little figure or this little example right here, and we went to these polygons right here, would you say these right here would be concave or convex? Well, the top left-hand one is our pentagon again, so we already talked about that. The one to the right of that would be called a what? How many sides is it? How many sides? 7. What's a 7-sided figure? Not a septagon, but a heptagon. So would you say this is concave or convex? Would you say that one's concave or convex? It's still convex, right? It's not going to go on the inside. But notice this arrow one, right? If I did this arrow one, and I drew the line here, see how it, then when I extended that line, it went into the inside of the figure? That's what makes it concave. So this would be considered inside, and extensions of sides would go inside the shape. I remember this as concave. If you cave something in, it goes in. So that's how I kind of remember concave versus convex. Make sense? So from there, we're just saying this is kind of the basic thing, but all polygons then are named by the number of sides. And this is where we start talking about the words then. So, we already talked about this. My smallest shaped would be a 3-sided figure, and hopefully we all know what a 3-sided figure is, right? That's what? A triangle. How about a 4-sided? Now this is where we're going to start getting more technical. Because a lot of people say, well, it's a 4-sided figure, so it's a what? A lot of people say it's just a square. But a 4-sided figure is not a square. A 4-sided figure is a what? No, same thing basically. Okay? Don't say a rectangle, that's not being specific enough. There you go. 4 means quad. So we have a quadrilateral. And then we have all these prefixes, right? The rest of them after 4 you're going to have a prefix, and then it's going to have gone at the end. Okay? So what's 5? We already talked about 5. Well, what's 5? Penta, right? 6? Hexa. 7 we already said, but what was it? Hepta. 8. Octagon. What's an octagon? A what? Ladies and gentlemen, octagons are stop signs. Stop signs are octagons. If you find a stop sign that's not 8-sided, it's not really a stop sign.
So we don't have to stop?
It's wrong. The one class I had it was bound and determined. There's a 6-sided stop sign in Lawton. I said, well, next time you go by it, take a picture because it's not a stop sign. Trust me, it's not. Okay? 9. What do you think? Nonagon. 10 is what? Decagon. Okay? The rest of the table is on page 57. Any idea what 11 is?
11 going.
It's called a hendagon. I don't know. And what's 12? Number 12 is dodecagon.
So just stop. Yeah, can you stop?
Okay? So 12 is usually where you stop. Now, somebody said it over here. What'd you say, Lauren, when I asked what 11 was?
11 going?
Yeah. Ladies and gentlemen, if you forget the names, you can always say whatever gone. You can. So if you don't know what it is, you can say that it's a 22 gone. I don't know what the name or the prefix for 22 is. If you forget that an octagon is 8, you can say an 8 gone. Okay? So you can say whatever sides it is and then put gone on it. It's totally legal. All right? What I'm going to name this then, besides the prefix and whatever it is, so name by the number of sides, plus the vertices in order. So if we came back to our first pentagon here and we called it, I don't know, what's a 5-letter word? S-T-U-V-W. Yeah? It's not a word, but I just have to make sure that I go in order. Now, each of us might start in a different place. Okay? So Merrick might start at the T, but Ryan starts at the U. That's totally fine. We're still talking about the same one. They just have to make sure that they go around in order. And it doesn't matter if you go clockwise or counterclockwise. You just have to go in order. So if Merrick went T, S, W, B, U, and Ryan started at U and went U, B, W, S, T, it's still the same thing. So in this case right here, I'm going to say, for my example, it's a pentagon. And then I'm going to start somewhere. S-T-U-V-W. That's how I'd have to write it. Okay? Or I'd say octagon and whatever it is. But again, all of these are going to have gone on them. These are all my prefixes. Okay? Make sense? Aren't you glad you did this now, Kenzie? You're learning so much about math. So the next thing that we talk about, this is really important, but it's not going to be really important until way at the end of the year. So I don't know if you'll remember it. But the next thing that we talk about are regular polygons. Any idea what this word means right here? If something is regular, normal, what's normal? Any idea? So regular polygons means all the sides and angles are congruent to each other. Now, obviously, the angles aren't congruent to the sides, and the sides aren't to the angles, but all the angles are congruent to each other. So it's basically a perfect whatever. So when we talk about the pentagon in, here's a little question we always have an argument with. Where's the pentagon? The true pentagon.
Tennessee.
Everybody says Washington, D.C., right? You're wrong.
Maryland.
It's in Arlington, isn't it? It's not in Las Vegas. No. It's in Arlington, Virginia. Anyway, so the Pentagon, if you looked up a picture of the Pentagon, it's perfect, right? On the outside, it's a perfect Pentagon. All the sides are exactly the same thing. Okay? So, a stop sign is a perfect octagon, right? All the little pieces of a stop sign, if you look out the window and look at the corner, all those pieces would be exactly the same. This is really, really important, and it's going to be really important when we get to area. Okay? Area, if you have regular polygons, easier to do than if I have a weird polygon, or a polygon that's oddly shaped. Okay? But we'll talk about them a lot more. Okay? So basically just a little introduction today. And then in this section, we talk about perimeter. What's perimeter? Distance where? Yeah, the distance around the outside of the shape or figure that we're talking about. So, if I want to, or if I'm asked to find the perimeter, I'm just going to have the sum of all the sides. So again, if it's a regular polygon, then all my sides would be the same. How would somebody tell me if this pentagon right here is a regular polygon, or a regular pentagon? How could they show everybody that? Okay, you can measure them. What? The little slashes, right? So if they came here and put little slashes all the way around, Cam, do you need to go somewhere?
Might be a possibility.
Yeah.
I just think they kind of bleeding everywhere.
I see that. Take your mask away.
Yeah.
We'll get your books later.
Okay.
Somebody get his books. Hey, you go to the nurse. Somebody get his books for him. All right, we'll finish tomorrow.